The responsibilities of external auditors in auditing information technology are vital for ensuring the integrity of financial statements, protecting against fraud and errors, and complying with regulatory requirements. With the increasing reliance on IT systems in today's business environment, auditors must adapt and expand their procedures to address the specific risks associated with technology. This ensures that financial reporting remains trustworthy and credible. In an IT environment, there are various issues and potential errors that can be introduced, which can lead to operational disruptions, security breaches, and data integrity problems. For example, input processing errors can result due to mistakes in data entry, configuration changes, or other manual processes. Systematic errors are consistent and repeatable errors that occur due to a consistent flaw or bias in a system, process, or procedure. They tend to affect IT operations or measurements consistently in the same way each time they occur. These errors are usually caused by a specific, identifiable, and persistent issue within the IT environment. They can result from misconfigurations, hardware faults, software bugs, or human errors that occur predictably. In contrast, random processing errors are unpredictable and non-repetitive errors that occur due to various random and uncontrollable factors. They do not follow a consistent pattern and can vary from one instance to another. These errors result from factors that are difficult to anticipate and control. They can be caused by human mistakes, equipment variability, external disturbances, or other unexpected events during IT processes. The IT environment lacks a paper trail as compared to manual processes, which inherently create a paper trail through the physical documents generated and maintained. Auditors can review these records to trace the history of transactions and decisions, whereas in an IT environment, financial auditors need to be able to analyze electronic audit trails generated by the IT systems. This requires the ability to interpret IT logs, identify anomalies, and trace the flow of financial transactions. Another issue is unauthorized access. Inadequate access controls can allow unauthorized individuals to gain access to sensitive data or systems, leading to data breaches and unauthorized actions that can disrupt operations. Despite the potential benefits of automation, reduced human involvement in processing transactions in an IT environment can introduce several challenges and issues. For example, with reduced human involvement, there may be limited oversight and control over the automated processes. This can make it difficult to intervene or make real-time adjustments in case of errors, exceptions, or unexpected situations. There's also the potential for dependency on system reliability. Increased automation means a higher dependency on the reliability and performance of IT systems. Any system failures or glitches can disrupt transaction processing, potentially leading to downtime and financial losses. Also, there's a lack of decision-making flexibility. Automated processes follow predefined rules and workflows. In situations requiring judgment, flexibility, or exceptions, automated systems may struggle to adapt, potentially leading to suboptimal decisions. The determination of the reliability of controls in an IT environment involves a series of audit phases that are critical for evaluating the effectiveness of IT controls in ensuring the integrity of financial reporting. In the initial phase, determining the scope of the IT testing plan and identifying IT dependencies, auditors focus on understanding the IT environment, defining the scope of their IT testing plan, and identifying IT dependencies that play a crucial role in financial reporting. The objective is to set the groundwork for IT control assessment. Some key activities include auditors analyzing the organization's IT infrastructure, applications, and systems. They identify key IT systems and processes that have a significant impact on financial reporting. This assessment helps auditors understand the technology landscape. Auditors also identify IT dependencies that are critical for financial controls. These dependencies can include software applications, data sources, databases, networks, and third-party systems or services. Auditors determine how these dependencies relate to financial processes. Based on the assessment and IT dependency identification, auditors define the scope of the IT testing plan. This includes identifying which IT systems and controls will be subject to evaluation and testing. With the scope defined and IT dependencies identified, auditors move on to the testing phase, where they assess the effectiveness of IT controls that are relevant to financial reporting. Some key activities include the selection of controls. Auditors select the specific IT controls to be tested based on their significance to financial reporting and the identified IT dependencies. Auditors carry out detailed testing of these IT controls. This involves a variety of activities, including examining system configurations, access controls, data integrity checks, and system logging. Auditors may also perform security testing and assess data accuracy and completeness. Auditors assess the results of control testing to determine the effectiveness of IT controls. They identify control deficiencies, vulnerabilities, or weaknesses. Material weaknesses and significant deficiencies are documented and communicated to management. IT controls are essential mechanisms that help organizations safeguard their information technology resources, maintain data integrity, and ensure the confidentiality and availability of data. IT controls can be categorized into two broad types: general IT controls and automated application controls. General IT controls, often referred to as ITGCs, are overarching controls that apply to an organization's entire IT environment. They're designed to provide a stable and secure foundation for the IT systems and applications within an organization. Categories of general controls include access controls, which are security measures that organizations implement to regulate and manage access to their physical and digital assets, systems, applications, and data. Access controls ensure that only authorized individuals are granted access while preventing unauthorized or malicious access. There are several components and methods involved in access control, including authentication, authorization, and audit trails. Authentication is the process of verifying the identity of a user, device, or entity attempting to access a system or resource. It confirms that the user is who they claim to be. Common methods include username and password, biometric authentication, smart cards, two-factor authentication, or multi-factor authentication. Another area of access is authorization, which is the process of determining what actions or resources a user, device, or entity is allowed to access after they have been authenticated. This is typically based on roles, permissions, or rules defined in the system. Authorization can be quite granular, allowing different levels of access based on specific attributes. For example, in a file system, a user may be authorized to read but not write or delete a file. A manager may be authorized to access certain confidential reports, while other employees are not. Audit trails are also a crucial component of access controls that record and monitor all access-related activities. These logs track who assessed what, when, and what actions were taken. They are essential for security monitoring, compliance, and investigation in case of security incidents. For example, in a secure database system, an audit trail records who assessed specific records, what changes were made, and the date and time of those actions. This information is crucial for identifying unauthorized access or suspicious activities. Consider an email system. Access controls are used to protect the email system from unauthorized access. Here's how controls are applied. Authentication. When a user wants to access their email account, they must enter a username and password. The system verifies that the provided credentials match the stored data for that user, ensuring that they are the authorized user of that account. After successfully authenticating, the user is granted access to their email account. Depending on their role, they may have different levels of authorization. For example, regular employees may only have access to their own email, while administrators may have access to all email accounts for maintenance purposes. The email system logs all access-related activities. It records who logged in, when they logged in, and what actions they performed. If there is any unusual or unauthorized access, these logs can be used for investigation and security monitoring. Change management controls are a set of procedures and practices that organizations put in place to manage and govern changes to their information technology systems, applications, infrastructure, and configurations. These controls are essential for ensuring that changes are implemented smoothly, do not disrupt business operations, and maintain the security and integrity of the IT environment. Change management controls typically include processes for requesting, reviewing, approving, testing, and documenting changes. For example, change management begins with the submission of a formal change request. This request details the nature of the change, its purpose, and its expected impact. Changes are reviewed by a designated change review board or committee, which assesses the potential risk and benefits of the proposed change. The board decides whether to approve, reject, or defer the change. Approved changes are tested in a controlled environment to ensure they function as intended and do not negatively affect existing systems. This phase may involve testing in a staging environment or through pilot implementations. A complete record of the change, including its planning, execution, and results, is documented. This documentation is critical for maintaining an audit trail and for troubleshooting. Before making changes to the production environment, a detailed plan is created. This plan should include steps for implementing the change and a rollback plan in case the change causes unexpected issues. Computer operation controls are designed to manage, monitor, and safeguard computer operations and data processing activities. They help in preventing disruptions, errors, and unauthorized access, ensuring the integrity and availability of IT systems. Key components of computer operation controls include batch processing controls, which ensure the accuracy and completeness of batch jobs that are scheduled to run automatically at specific times. Batch processing controls include error checking, job sequencing, and verification of job outputs. Data backup and recovery procedures are controls that involve regularly backing up critical data and systems and establishing procedures for data recovery in the event of data loss or system failures. Backup schedules, storage, and recovery testing are part of these controls. Job scheduling controls govern the management and sequencing of various IT jobs, such as system updates, data processing, and report generation. They ensure that jobs are executed in the correct order and with proper resource allocation. Environmental controls encompass measures to maintain the physical environment in which IT equipment operates. This includes regulating temperature, humidity, and fire suppression systems to prevent hardware damage or system failures. Security and access controls protect the computer operations from unauthorized access, both physical and digital. This involves securing data centers, servers, and systems, as well as implementing user authentication and authorization procedures. Also, change management controls, as previously discussed, regulate changes to the IT environment, ensuring that updates, patches, or configurations are made without causing disruptions or vulnerabilities. Program development controls refer to the set of procedures and practices implemented to manage and govern the process of developing, modifying, and maintaining software applications. These controls are essential for ensuring that software development projects are executed efficiently, meet quality standards, and adhere to organizational policies and industry best practices. They help in preventing issues like programming errors, security vulnerabilities, and project delays. Key components include project management and planning. Effective program development begins with comprehensive project planning. This includes defining project objectives, scope, resource allocation, timelines, and milestones. Project management controls help ensure that the development process is well structured and that the project progress is monitored. Clear and well-documented requirements are crucial for successful software development. Requirement management controls help in gathering, validating, and management project requirements. They also include procedures for handling changes to requirements. Clear and well-documented requirements are crucial for successful software development. Requirement management controls help in gathering, validating, and managing project requirements. They also include procedures for handling changes to the requirements. Establishing coding standards and guidelines is also essential to promote consistency, readability, and maintainability of the code. These controls define the programming practices, naming conventions, and coding styles to be followed by developers. Version control systems track changes to source code, allowing for collaboration among developers, code history tracking, and the ability to revert to previous versions if needed. Change management controls help in tracking, reviewing, and documenting code changes before they are implemented. Testing controls include defining the testing strategy, developing test plans, and conducting various types of testing, such as unit testing, integration testing, and user acceptance testing. Quality assurance controls focus on ensuring that the software meets the quality standards and functional requirements. Given the importance of software security, these controls help in identifying and addressing potential security vulnerabilities during the development process. They may include code review, security testing, and vulnerability assessments. It is important to document and report the controls. There should be a comprehensive document including design specification. Documentation should be comprehensive and include design specifications, user manuals, and system documentation. Reporting controls ensure that progress issues and project status are communicated to stakeholders. The review and approval process should include controls related to the review and approval processes should include controls related to code reviews, design reviews, and approval processes. Help in ensuring that code and design changes are thoroughly evaluated and meet the project's objectives. Compliance and audit trail controls ensure that the development process complies with relevant regulatory requirements and organizational policies. They also establish audit trails for code changes, testing results, and project documentation. Overall, program development controls are essential for minimizing development risk, maintaining code quality, and delivering software that meets user expectations. These controls may vary in their specific details and implementation, depending on the organization's size, industry, and the nature of the software being developed. They provide a structured framework for the entire software development lifecycle, from project initiation to release and maintenance. In contrast to general IT controls, which are foundational controls that apply to the overall IT environment, automated application controls are specific to individual software applications or systems and are designed to ensure the accuracy and completeness of data processed by those applications. They can be further categorized into three main types. The first category is input controls. Input controls focus on the accuracy and integrity of data entered into a system. They ensure that data is complete, valid, and consistent. Consider an example of an input control in the revenue and collection application. Data validation. Before entering a new customer's payment details, the system validates that the payment amount is within an acceptable range. This prevents erroneous or fraudulent transactions. The system checks that the dates, account numbers, and other data fields adhere to the specified format, reducing the risk of data entry errors. Processing controls focus on the accuracy and completeness of data processing within an application. They ensure that transactions are processed correctly and that the integrity is maintained throughout the process. Examples of processing controls in the revenue cycle include reconciliation. The system will automatically reconcile payments received with corresponding invoices, ensuring that payments are correctly applied to the appropriate accounts. Automated billing is another example of a processing control. The application generates accurate invoices based on customer usage or agreed upon terms, reducing the risk of billing errors. Finally, output controls focus on the accuracy, confidentiality, and distribution of processed data and reports. They ensure that output is reliable and secure. Examples in the revenue cycle would include encryption. When generating financial reports, the application encrypts sensitive data to protect it from unauthorized access during transmission or storage. Access controls are another form of output controls. The system controls who can access financial reports, ensuring that only authorized personnel can view or print sensitive information. Audit trails are also an important output control. The application creates audit trails that log all financial transactions, providing a complete history of changes and activities within the system. This trail assists in tracking discrepancies or fraud. Identifying specific types of misstatements allows auditors to assess the risk associated with those misstatements accurately. Different types of misstatements may have varying levels of impact on financial statements, and understanding them helps in evaluating the overall risk to financial reporting. Knowing the types of misstatements that could occur provides insight into the weaknesses in the organization's internal controls. Auditors can then prioritize their efforts on critical areas where misstatements could have the most significant impact on financial reporting. After understanding the IT environment, auditors identify the key IT controls that are relevant to financial reporting. These controls can include general IT controls and application controls. Auditors assess the design of the identified IT controls. They evaluate whether these controls are appropriately designed to prevent or detect material misstatements. This involves reviewing control documentation, policies, and procedures. Auditors conduct tests to assess the operating effectiveness of these controls. This step involves selecting a sample of transactions or data and testing the controls to verify whether they are functioning as intended. It may include examining system configurations, access logs, and data integrity checks. Control deficiencies are categorized based on their severity. Auditors distinguish between significant deficiencies and material weaknesses. Auditors can test general controls by evaluating the design and operating effectiveness of the organization's overall IT control environment. Auditors can review the organization's program development policies, procedures, and documentation to ensure they are adequately designed and implemented. They can assess whether there are established guidelines for software development and coding standards. For example, the auditor may select a sample of software development projects and assess whether they adhere to the organization's software development policies. They can check if coding standards are followed, code reviews are conducted, and appropriate testing is performed before software is deployed. With respect to change management controls, auditors can assess the change management process by reviewing the records of system changes and evaluating the documentation of change requests, approvals, testing, and implementation. They can also test whether change management controls prevent unauthorized changes. As an example, auditors may select a sample of recent system changes and examine the associated change request documentation. They can confirm that the change requests were properly authorized, that testing was conducted, and that rollback plans were in place. They can also verify that changes were implemented as per the approved request. For computer operation controls, auditors can evaluate computer operation controls by examining documentation and conducting observations. They may review records of system downtime, monitoring and alerting procedures, and backup and recovery plans. The auditors may observe the operation of backup and recovery procedures by initiating a test recovery of a selected system or data. They can also review records of system downtime and assess whether monitoring alerts were appropriately responded to and documented. Finally, with respect to access controls, auditors can assess access controls by reviewing user access lists, user permissions, and security logs. They may also perform user access testing to verify whether user accounts are properly configured and access is limited to authorized personnel. The auditor can select a sample of user accounts and examine access permissions. They can validate that user accounts are consistent with the individual's role in the organization. The auditor can also review security logs to verify that unauthorized access attempts are logged and responded to. In each of these examples, auditors are evaluating general controls by examining policies, procedures, and documentation, and by testing the operating effectiveness of those controls. The specific audit test will depend on the organization's control environment, risk assessment, and audit objectives. These tests help auditors determine whether general controls are effectively designed and implemented to support the reliability and security of IT systems and data. Auditors test automated application controls by evaluating the specific controls implemented within an application to ensure the accuracy, completeness, and security of data processing. These controls are critical for maintaining the integrity of transactions and data within the application. Auditors can test the effectiveness of input controls by examining the accuracy and integrity of data as it is entered into the application. This can involve validating data input for completeness and accuracy and ensuring that data meets predefined criteria. As an example, in a financial application, auditors can select a sample of financial transactions and verify that the input data, such as transaction amounts and account numbers, is accurate and complete. They can also assess the application's ability to reject or flag entries that do not meet specific validation criteria. With respect to processing controls, auditors can assess processing controls to ensure that data processing within the application is complete and accurate. They may examine the application's ability to perform calculations, validations, and data transformations correctly. For example, auditors can select a sample of financial transactions and trace them through the processing cycle. They verify that calculations such as tax calculations, interest calculations are accurate and that the application performs all necessary data transformations such as currency conversions or data aggregations as expected. Finally, output controls are evaluated by examining the accuracy, confidentiality, and distribution of data and reports generated by the application. Auditors assess the reliability of the output, data protection, and appropriate access. For example, in a payroll application, auditors can review the generated payroll reports for accuracy. They verify that employee salaries, deductions, and tax withholdings are correctly reflected in the report. Additionally, auditors check that only authorized personnel have access to sensitive payroll reports and that output data is not exposed to unauthorized individuals. It is important to note that the specific tests and procedures may vary depending on the organization's processes and the nature of the application being audited. Auditors must tailor their tests to address the unique risk and requirements of the application. These tests help ensure the integrity and security of financial data and transactions within the application.